Now, the topic that we are going to discuss today, okay, is going to be redox reaction. Now, redox reaction is a reaction where, okay, it's a combination, okay, reduction and oxidation. So, it is going to be two reaction, okay. So, in order to have redox reaction, you must have oxidation and reduction happening at the same time. Okay, so both of them must be happening together. So that's why you have redox. Redox means RED is going to represent reduction. OX is going to be oxidation, redox reaction. Now, for this redox reaction, what we need to know is, we need to know what is oxidation and what is reduction. Okay, so what is oxidation? Okay, what is reduction? There are four ways to define them. Okay, what are the four ways to define them? Okay, one, the basic stuff, okay, when we represent oxidation means oxidation is you receive oxygen. Okay, you receive oxygen, or when there is going to be addition of oxygen atom, okay, that is going to be oxidation. So I'll just put down over here your first definition is going to be whenever there is going to be increase in number of oxygen atom. Okay, and reduction is going to be, okay, the other way around, when there is going to be reduce in oxidation atom, oxygen atom. Okay, one example that we can look at is going to be whenever you have, okay, for example, magnesium plus oxygen, okay, and you are going to get magnesium oxide. This is one example, okay, of oxidation reaction. But is this reaction, magnesium plus oxygen, to give you magnesium oxide, is a redox reaction? The answer is no. Okay, redox must be both of them. Yeah. So in this case, this is oxidation. Okay, let's look at reduction. Oxide reacting with hydrogen, they are going to give you copper and water. Okay, this is one example. Okay, this example is found in your textbook. Okay, where you have copper oxide. Okay, you react with hydrogen. Okay, and you will have copper and water. But if you look over here, okay, this copper oxide, okay, it's losing the oxygen atom to become copper. So you can actually say which one is going to be reduced over here. This is very important. The one that is going to be reduced over here is copper oxide. Copper oxide is the one that is going to be reduced. Okay, because copper oxide is the one that is losing the oxygen. Okay, so this is going to be reduction. Okay, if you are using the first definition, okay, on how to define oxidation and reduction. Now, the second way, okay, to define them, okay, is going to be something that is quite interesting as well. Okay, which is going to be known as, okay, what we call as oil rig. Okay, you can actually use this, yeah, to remember. Oil rig, okay, oil means oxidation is loss of electron. Okay, so the number 2 is loss of electron. And this is reduction is gain of electron. Okay, so this is going to be number 2 is when you add electron. Simple way to look at it is by looking at half equations. What are half equations? It's just a part of the equation. Half plus another half will give you a complete ionic equation. Yeah. So half equation. So in half equations, there will be electrons. Please remember that. Okay, half equations, there will be electrons. Okay, ionic equation do not have electron. Please remember that. Because ionic equation, we learn you remove the spectator ions. Okay, and in this case, this is not ionic equation. This is half equation. Half equation we normally use in electrolysis. what will happen at cathode, what will happen at anode, and then we join them together and we write the entire equation. So in this case, it is more suitable for electrolysis. Okay, but if you look over here, I'll give you one example. When do you lose electron? Yeah, in this case, maybe if you lose electron, copper. Okay, when copper lose electron, they are going to give you copper 2+ ion. So how many electrons do they lose? To get 2+, you must lose 2 electrons. And in chemistry, we don't write -2 electrons over here. Okay, we just write down minus electron, go where? It goes there. So we write down +2 electron. In this case, which one is going to be oxidized over here? Because copper is the one that is going to be losing the electron. So oil rig, oxidation is loss of electron. Therefore, copper is the one that is going to be losing the electron, which is copper is the one that is going to be oxidized. Okay, and if you look at plus electron, you can change this. Okay, let's say for example, you have copper 2+, and I have, okay, I gain the electron, 2 electron. Okay, and then I am going to give you copper, okay, solid. So in this case, you can see that copper 2+ is the one that is gaining the electron. So if I ask you which one is going to be reduced, your answer will be copper ion or copper 2, the ion itself. Okay, students miss that part. Just simply write Cu. It's Cu2+. Okay, it's the one that is going to be reduced. Okay, it's going to be now if you're using the electron to look at it. So the second way to look at it is by using the oil rig. Now, the third method, we will come back into this again. The third method is going to be by looking at oxidation number. I use ON. What is ON? Oxidation number. And we will go into oxidation number in a while. Okay? Increase in oxidation number. And number 3 here is going to be decrease in oxidation number. We'll go into this later. And I will come back and revisit this again. Now, the fourth way, which is not very common, okay, the fourth way is going to be something opposite than the first one. And it is related to hydrogen. And this is more towards, okay, whenever we learn about organic chemistry. We haven't learned that. Okay. Whenever we learn about organic chemistry, okay, we always learn something, reaction with hydrogen. Not this kind of hydrogen. This is not organic. Organic chemistry means something that has carbon and hydrogen, okay, like alkane, alkene, and so on. So when we use H2, okay, I'll give you one example. If I have like this, and I go and add hydrogen, this is going to be known as hydrogenation reaction, and it requires catalyst. Okay, and what happens over here is the double bond is going to be broken, and you will have hydrogen being added. Now, when hydrogen is being added, it's opposite than this, yeah. So this is going to be, when you add hydrogen, that's going to be known as reduction. So the reaction with hydrogenation, yeah, the hydrogenation, okay, reaction with the alkene, it's also known as a reduction process. Okay, it's a reduction process by using hydrogen. So we will not learn now, okay, it's not so popular, okay, but just another one more, yeah. So this one is opposite. So if you lose hydrogen, the first definition, gaining, okay, of oxygen atom or losing oxidation atom. Second is to remember that oil rig, oxidation is loss of electron, okay, reduction is gain of electron. And the last one, which is going to be very helpful when we write down about, okay, the oxidation number, okay, which is going to be gaining of oxidation number and losing oxidation number. So now, okay, what I want to actually go through now, okay, is to go through about, okay, oxidation number, because I still want to relate to this. Certain things, certain rules that we need to follow. Okay, oxidation numbers. Okay, there are some basic rules and there are some exceptions. Okay, and what we are going to do is to just go through the basic rules first. Number one, okay, the rule number one is going to be, okay, when we look at oxidation number of elements, okay, elements will be always 0. Okay, elements will be always 0. I'll give you one example. Okay, P4 is element. Okay, S8, sulfur, is also element. The oxidation number is going to be 0. Okay, element. I give you another element. Copper metal is element. So when they are existing just like that in the equation, the oxidation number is 0. So the second one, okay, is going to be when we are looking at certain compounds. Okay, certain compounds, okay, we are going to have certain elements, okay, that will follow certain oxidation number. For example, okay, if I have oxygen, okay, if I have oxygen in a compound, oxygen generally will have oxidation number of -2. Okay, always -2. But there are some exceptions. And we are not going to use this exception all the time. Okay, the exceptions are when you are having peroxides. Okay, this one no need to memorize now, because generally when you do the calculation, most of the time oxygen is -2. Peroxides, what are peroxides? Hydrogen peroxide. Okay, the oxygen inside here, okay, it is going to be always -2. Sorry, always -1, sorry. Exception, yeah? Always -1. So peroxide, oxygen is going to be -1. Now hydrogen, okay, most of these, group 1, okay, group 2, they tend to follow the group number. Like for example, potassium. Okay, potassium in compound, they will give you +1. Okay, it means, okay, we are still talking about in compound. Okay, so certain group 1 elements, group 2 elements, okay, they will actually follow +1, +2, and so on. So potassium in a compound, let's say for example, KCl, K is +1, follow the group. Okay, Cl also going to be follow the group, which is going to be group 7, they will form -1. Cl is -1. Okay, so there are some exceptions. On top of this exception, there is another one more exception, which is going to be related to F2O. Now, F in a compound, this is also special. F in a compound is always going to be -1, always. Okay, in a compound. So if it is -1, you see this one must be -1. -1 times 2, -2. Okay, so this one must be +2. Okay, later I'll explain to you further. Okay, but the exception, okay, in F2O, oxygen is +2. And we don't use this often. Yeah, I'll just put this. This is extra knowledge. Okay, even fluorine also we don't use this often. Okay, so this is just, okay, extra knowledge. But I'll go to the important part, number 3. Number 3 is if the compound is neutral. Okay, if the compound is neutral, neutral compound, the overall oxidation number equals to 0. A neutral compound. Generally, most of the compounds that we have are generally neutral. What are neutral compounds? H2O is a neutral compound. KMnO4 is a neutral compound. What does it mean? It means that the overall oxidation number is 0. Now, this will explain about the oxidation number of F2O. Now, you see here, F2O, the overall oxidation number is 0. So, it means that we know that F always negative 1. Negative 1 times 2 is negative 2. Oxygen you don't know. Let's say we put X. Overall is going to be 0. And X equals to plus 2. So you can calculate. So this is one of the way to calculate. Yeah, there are certain things that you will know, certain things that you need to calculate. Now, number 4, because of this, is going to be easy to remember. Number 4, ions. Okay, ions will always follow the charge. Let it be positive ion, let it be negative ion, they will follow the charge. Example, if you have Cu2+, what is the oxidation number? Positive 2. If I have Cl-, what is the oxidation number? Negative 1. If I have something more complicated, MnO4-, the entire, okay, this entire thing, okay, the oxidation number is negative 1. Now, if I ask you, calculate the oxidation number of Mn over here, can you calculate? You don't know. It's not part of it. Can you calculate the oxidation number of Mn over there in MnO4-? You should be able to calculate. Why? Because Mn, you just put X. Oxygen, generally, the oxidation number is what? Negative 2. So, 4 times negative 2 equals to what? Minus 1. So, X equals to negative 1. This is minus 8. Bring it over there. Plus 8. So, this is going to be plus 7. Oxidation number of Mn is plus 7 in this particular ion. Okay. That is the reason why we refer this as potassium manganate 7 in IGCSE. Potassium manganate 7 means the oxidation number of Mn is 7 and you have calculated. Okay? Hydrogen, okay, will be always positive 1. Okay, hydrogen will be always positive 1 except for metal hydrides. Okay? Metal hydrides means, like for example, NaH. If you have metal hydrides, okay, hydrogen will become negative 1. This is negative 1. Easier to remember also. Why? Sodium is always positive 1. Sodium is positive 1. Okay. Hydrogen you put as X. The entire thing is 0 equals to 0. X equals to negative 1. Hydride is just a way, like for example, hydride is H- ion. Okay, H-. So they call it NaH, metal hydride. Okay, so we have that. Okay, now it is important, okay, for us to learn, okay, why we use oxidation number. Okay, because, okay, last time when you learn about, okay, this oxidation number, okay, we also learn about, okay, potassium acidified potassium dichromate. And then there is a bracket and there will be a number over there. Anyone can remember what is the number? There are two important regions that you need to remember in chemistry. Potassium manganate and this one, potassium dichromate. Okay, potassium manganate and potassium dichromate. Now, so I will write down again, yeah, potassium manganate KMnO4. Okay, KMnO4, potassium manganate. And potassium dichromate is written as K2Cr2O7. And there is always, okay, when we write down the full equation, when we name this chemical, we name them, okay, because this can only work under acidified condition. So we always say acidified potassium dichromate what? Okay, and acidified potassium manganate what? Okay, so just now I showed that you can calculate the Mn, which is acidified potassium manganate 7. Now you can do the same calculation here. There are two ways to do this calculation. The aim is to look at the oxidation number of Cr, chromium. You can do the normal method. The normal method is K is group 1 in a compound, so plus 1. So 2 times plus 1 plus X. How many X? 2X. And then 7, negative 2. Oxygen is always negative 2. Overall is 0. So what you need to do, you just need to calculate the X. Rudy, turn off your iPad, look over here. Okay, and you get X as positive 6. And this is the oxidation number of chromium. And chromium, we say acidified potassium dichromate 6. That's the reason why we say acidified dichromate 6. Because 6 is going to show the oxidation number of chromium. Okay, now, this is the same example why we have special names for these two. Okay? Can you name the first compound? Can you name the second compound? Yeah? What this? Copper oxide. What is this? Copper 2 oxide. Copper what? Copper dioxide, carbon dioxide, dioxide means 2 oxygen. Yeah. So if this one, okay, when we name, please remember, it is in both of them, okay, are copper oxide, but they are different. Why they are different? Okay, because you would have learned that copper are transition metals. And transition metals in IGCSE, we have learned that they have variable oxidation number. Okay, so we are dealing with oxidation number now. Okay, now if you look over here, oxygen is always 2 minus. Okay, so if you separate this, copper, okay, and then oxygen 2 minus, CuO. It means what is the charge that's supposed to come over here? Plus 2, which is 2 plus. Yeah. Then you will have CuO. So if I want to actually tell what is the oxidation number of copper, copper will follow, the ion will follow the charge, which is the oxidation number is going to be plus 2. So how do I write this name for this compound? This is going to be copper 2 oxide. It means this 2 is going to represent the oxidation number of copper. If the number comes at the end, it is going to show the oxidation number of chromium, not potassium. If they come at the middle, then they are going to show the oxidation number of this. Okay, so in this case, this is copper 2 oxide. So what is the name of this compound then? Okay, if you need Cu2, yeah, so it means that oxygen is 2 minus, and you need to times by 2. Why you need to times by 2? Because you want to make it same as this. So this one should be plus 1. So this is plus 1. Copper is plus 1. If you cannot see, you just Cu plus and O2 minus. How to write them together, put them together? I need to make this number and this number the same. So I need to times by 2. Okay, then only I will get plus 2. So it means why times by 2? It means I need 2 Cu plus. Okay, so it means that you have Cu and then 2 Cu plus, and then 1 O. So what does it mean? This is plus 1 oxidation number. So the name of this is copper 1 oxide. Okay, copper 1 oxide. And we have seen copper 1 oxide in one of our practical. Remember the part that you burn something until it becomes black solid? That is copper 1 oxide. Copper 1 oxide is black solid. Okay. Now, so generally these are some of the common rules. Okay, as I think it's enough for you to know. Yeah, if you put it over here, if I want to know what is the most important rule over here, the most important rule is elements is 0. Oxygen is always -2. Hydrogen is going to be always +1. Neutral compound, everything is going to be 0. And if it is going to be ion, they follow the charge. Okay, these are the common things that you need to know. If there is going to be something that, let's say a guideline, yeah, in your textbook, there are more. Okay, there are more. Okay, but the one that you will use in practice will be this one. Okay, and now let's actually come back and look again. Yeah, so basically, what is redox reaction? Is a reaction that has both reduction and oxidation at the same place. Okay, so it's a reaction that involves both reduction and oxidation. And one of the examples just now that you gave, yeah, I will use this again. Copper oxide plus hydrogen to give you copper plus H2O. Now, we'll also use another reaction. Okay, also to show this. Now, if you look at this equation, the first equation, okay, the first equation, you can actually say that copper oxide, okay, is being reduced to become copper. Okay, so they become copper. So quite easy. But let's say I don't want to use this method. I want now to look everything using oxidation number. Or let's keep that. Okay, Rubik's Cube. Okay, follow here. If let's say now I want to look everything using oxidation number. Okay. What is the oxidation number of copper? 2 plus. Okay, please remember this is in a compound. Okay, and if in this case you see this is 2 minus. Of course, this one will be 2 plus. So this one is plus 2. Okay, plus 2. What is the oxidation number of copper over here? Here. It's an element. Element is going to be 0. What happens here? Reduce in oxidation number or increase in oxidation number? 0 plus 2 to become 0, decrease. So it means that there is a decrease in oxidation number, you can say this is going to be reduced. Copper oxide is reduced. So now you are using oxidation number to look at it. Okay, this is very useful as well. Okay, now let's look at hydrogen. Now what is, okay, to answer your question, yeah, what is the oxidation number of H2? Together, 0. Okay, what is the oxidation number of hydrogen here? Okay, this is hydrogen always what? +1. Okay, hydrogen is always +1 except for metal hydrides. Okay, and you can see from here to here, 0 to become +1. This is going to be gaining the oxidation number. So we can say hydrogen is going to be oxidized. Okay, hydrogen is oxidized. And you can see also here, hydrogen is gaining oxygen. It is oxidized. But I'm using oxidation number over here to explain. Okay, now I can also use my oxidation number to also explain whenever it comes to half equations. Now for half equations, copper 2 plus 2 electron to give you copper. What is the oxidation number of copper 2 plus? Waldes? No laptop during class. Oxidation number of copper 2 plus? No. Ion will follow the charge of the ion, +2. What is the oxidation number of copper? 0. What happens? +2 to become 0. Reduce. Okay, copper 2 plus is being reduced over here. And what we learn under reduce? Reduce means oil rig, RIG. Reduction is gain of electron. You see, this is gaining electron. So you can use oxidation number in everything. This is very important. Okay. Now, I'll teach you one more important thing. Yeah, maybe I'll teach you two important things. Yeah. This one. This one. Because it's ion. Remember when we look at the general guideline to follow, ions will follow the charge. Copper 2 plus. Yeah. Yeah, but not copper 2 plus. We are talking about the ionic equation. If you have ionic equation, you just follow the ion. Okay. Even though they are under transition metal, CuO and Cu2 plus, Cu2O, within itself also they are different. The oxidation number of this is +2, oxidation number of this is +1. Okay, but this one is actually because it's Cu2 plus. It's already follow the charge. This one is Cu plus and O2 minus, follow the charge, +1. Okay, you just need to follow the charge. Now, why I am teaching you this? Because now we will focus 100% on half equation. Okay. Now, one of the common reactions that involves half equation is going to be the electrolysis reaction. And let's say we have cathode and we have anode. Even sometimes, even until now, students do not know what is cathode, what is going to be anode. Okay. Now, electrolysis is different than electrochemical cell. Okay, what is the difference? Electrolysis using electricity. Electrochemical cell do not use battery. They can happen because of difference in potential energy of the different electrode that you use. That is electrochemical cell. Electrochemical cell, we try to generate electricity. Electrolysis, electro means electricity, lysis means breaking. We are using electricity to break down stuff. Okay? And let's say now I have copper sulfate solution, aqueous, and I have platinum. And then I have the battery. This is a very simple setup, okay, of electrolysis cell. Now, can you tell me which one is cathode, which one is anode? I don't know, you discuss, I don't know. Okay, you start from the battery. Okay, good. So plus, this is minus. Make sure you know this, yeah? Rudy, look over here. Okay, the long one is going to be plus, the short one is minus. Okay. So next, if you have positive over here, here you are going to attract positive or negative? Opposite charges attract, right? So negative will come over here. And if you have negative over here, positive comes over here. Okay? Now, when we are talking about negative and positive, we are talking about the electrolyte, which is going to be provided by copper sulfate, which is going to give you copper 2 plus and SO4 2 minus, positive ion and negative ion. But on top of that, it has aqueous. Aqueous will give you H2O to give you H plus and OH minus. So there are total 4 ions here. Okay, total 4 ions here. Listen carefully. Okay, because maybe you didn't learn so much on your IGCSE. Okay, in this case, okay, they are not going to focus on this, but it is expected for you to know. Here, the negative ion, these are the negative ions. SO4 2 minus, OH minus will come here. Positive ions, H plus will go there, and then Cu2 plus will go there. Okay, now, positive and negative ions, they are known as what? Positive ions in chemistry, they are known as? Start from the ion first. Cation means, okay, positive ion. Anion means, okay, negative ion. Okay, from where we have this name, okay, it's because of this cathode and anode actually. Okay, why? Because these positive ions are cations. Okay, cations, okay, will be attracted to this terminal, right? So this is going to be known as cathode because cations are attracted to cathode. Okay, and this is anions. Anions are going to be attracted to anode. Students always memorize negative, positive. No, you memorize this way. Okay, so they are going to be, this is going to be your anode, this is going to be your cathode. So now, my question is, what is going to happen at your anode? What is going to happen at your cathode? Okay, at your cathode, okay, you look at cathode, this is the cathode, you have H plus and Cu2 plus. One must be selected, okay. The one that is going to be selected over here is going to be the one that is going to be lower in the reactivity series, okay. And the one that is going to be lower in reactivity series is going to be copper, okay. In IGCSE, you learn, yeah. But, okay, that is how it works, okay, lower in the reactivity series. So, one will be selected, copper 2 plus will be selected. Generally, most of the time, H plus will be selected if you are using different metal, yeah. But copper 2 plus will be selected. So, copper 2 plus, okay, this is cathode, yeah, plus 2 electron, okay, and then they are going to become copper. So what will happen to copper? This one is going to be a deposit of copper will be formed at that platinum, okay. You can see a brown deposit over there. Okay, that is going to be the observation. And all the copper is coming from copper 2 plus. What can you observe in the copper sulfate? What is the color? It's a blue solution, copper sulfate. If blue solution, slowly you are using copper 2 plus. Copper 2 plus is the one that gives you the blue solution. Copper 2 plus, what will happen to the copper 2 plus? It's being used up. If it is being used up, the intensity of the blue color solution is going to be slowly will become faded. Okay, it will become faded. Okay, because copper 2 plus is being used up here. Okay, that is your observation, another observation. Now, what is another here? This one, okay, you need to go and revise your IGCSE again. Sulfate, okay, for now, okay, I will give you the easiest answer, but later when we go to JC2, you will understand better. Okay, sulfate is not going to be selected. Okay, OH will be selected. There are certain cases when we are using concentrated chloride or something, then chloride will be more, then Cl will be selected. Okay, but this one is under normal condition, OH minus will be selected. So OH minus, okay, is going to be selected to give you something. Now, why I'm writing all this? Because in the end, I just want to focus on this. Okay, selected to become what? This is very important. Now, in chemistry, there are, I think I repeated this many times. There are certain reactions only that can give you oxygen gas. Okay, the magic equation is when you have hydrogen peroxide, when you use the catalyst of MnO2, and you will get oxygen gas and water. Okay, that is decomposition reaction. Another reaction, okay, apart from photosynthesis to give you oxygen, another reaction is when you use, okay, electrolysis. And this is the part where you are going to get oxygen. Yeah. Now, OH minus will give you, first I'll write down first, it will give you oxygen. Okay. Hydrogen, it will be given out in form of water. Okay. And my task over here is to write the half equation. Maybe last time you memorized only. But now I'm going to show you how to write the half equation over this. This is not complete yet. Okay. So now, okay, you just need to look at, okay, how many, okay, let's say for example, if you have this, okay, how many hydrogen I have? I have, okay, only one here, I just put 2. Okay. Second is to look at oxygen, I have 2, but here I have 3, so maybe I put half. Okay. Better if I times everything by 2, easier to see. So which is 4. Then this one is 1, this one is 2. Okay. The last thing that you need to do is to balance the charges left and right. The charges over here is 4 times negative, so negative 4 charge. What is the charge over here? 0, no charge, 0. Not balanced actually. You need to balance the charge. How do you balance charge in half equation? By bringing in electron or proton, but we don't bring in proton. Okay, so we bring in electron. Okay, because we are dealing with transfer of electron. Chemical reaction, that's why it involves transfer of electrons. And you can bring in electron over here. If you bring in electron over here, it will become more negative. Electron is negative. You bring electron over here, you can make it negative 4 by adding 4 electron over there. So now, you'll become negative 4, negative 4, negative 4, balance. This is what we call as the half equation. Now, the reason why we have our half equation is because at the end, when you write down the equation, you can write the overall equation. Okay, you can write the overall equation. The overall equation is where the electrons can be cancelled. How do we cancel the electrons? Okay, we cancel the electrons, you see here. This is the electron is on the right. This is going to be electron on the left. 2 electrons, 4 electrons. You want to cancel, you times this by 2. Okay? Then you add this and this. When you add these 2 equations together, the 4 electrons and the 4 electrons will cancel automatically. Left and right, they will cancel. So what you will have is 2Cu2 plus 4OH minus to give you 2Cu plus oxygen plus 2H2O. This is going to be the complete, okay, the overall equation. And you see, overall equation do not have electron. Okay. Now, why I am teaching you this? So that you can overall visualize this and at the same time, look at the OH minus. One thing you need to remember, electron do not swim. Okay. Electron do not swim. Electron only move, okay, in an external circuit, in a better way, through the electrode, through the wire. Yeah, they do not swim. That is very important. What is actually moving in the electrolyte is the ions. Please remember that. Now, to answer Aurelia's question, electron move from where to where? Okay, you can see just now, this is negative ion, right? Negative ion is the one that lose electron. Positive ion is the one that gain electron, correct? Just now we wrote Cu2 plus 2 electron to give you copper, right? They gain electron. Remember, the copper 2 plus is here. They are swimming. Copper 2 plus. Where the electron comes? Electron don't come and swim over here. They come from the battery. They come to copper. So, electron comes from here to here. So, the movement of electron is actually, it goes here, and then this one is losing electron. The electron goes there. So, in battery, electron goes out from which terminal? Negative terminal. You can see. Negative terminal, electron goes out. Okay. From here to here, what completes the circuit? Must be something that conducts electricity. It means electrolyte must be something that conducts electricity. If you put something that do not conduct electricity, for example, oil, this reaction will not even happen. Okay, must be electrolyte. Okay, if you put sodium chloride, maybe sodium chloride powder, of course, doesn't make sense. But if you use HCl, okay, molten HCl, okay. Molten HCl, okay, it's still going to be in covalent state. HCl is a covalent compound. You melt HCl, it's still going to be covalent compound. There is no H plus and Cl minus. H plus and Cl minus comes from, okay, when you add water to HCl. Okay, then only you get H plus and Cl minus. But ionic compounds, if you melt ions, they will actually become free moving ion. There is no problem in that. But covalent compounds, you heat them up, you are breaking the intermolecular forces of the attraction only. You are still going to have the covalent compound. So students will get confused with molten HCl. Molten HCl is covalent. They do not conduct electricity. Yeah, please remember that. Even though they are in liquid form, okay, liquid doesn't mean that they can conduct electricity. Okay, molten HCl. Okay, remember KMnO4 and K2Cr2O7. Now these two, okay, potassium manganate and potassium dichromate, they are known as oxidizing agent. Okay, in chemistry, okay, we have oxidizing agent, or we can call it as oxidant. Okay, oxidant. Now, what is oxidizing agent? Oxidizing agent is something that can actually oxidize others, but itself will get reduced. Okay, something like an insurance agent. Insurance agent is going to sell you insurance. Okay, oxidizing agent is just going to sell you oxygen. Okay, it's going to oxidize you. Okay, they are going to oxidize you, but in the end, the insurance agent gets money. Yeah, so in this case, the oxidizing agent gets what? Okay, they are losing oxygen. If they are losing oxygen, it means they get reduced. Okay, so they are selling. Yeah, you can just remember someone selling you something. Okay, so it means that oxidizing agent is going to be something that is going to cause oxidation, but at the same time, they are going to get reduced. Okay, they are going to be reduced, and they are called as oxidants. Insurance agents, oxidizing agent, just make it shorter, oxidants. Okay, so oxidant agent, oxygen agent, or oxidants. Yeah. Now, oxidants. Now, there are two main or common oxidants in our lab, KMnO4 and K2Cr2O7. Okay, and the oxidation number we have already learned. This is 6. This is 7. This is 6. Okay, acidified potassium manganate 7. Acidified potassium dichromate 6. Okay, now I'll give you one simple example so that we can learn about balancing equation. Yeah. Now, they are oxidants. Let's say I am going to oxidize Fe2+. If I oxidize Fe2+, what will happen? Fe2+ becomes what? Ayo, Fe2+, Fe3+, Fe. I give you 3 options. Which one? Oxidize. So it means Fe2+ become Fe3+. Yeah. So I write down, yeah, Fe3+, okay. Where do I put the electron? This is losing electron, so this one is plus electron. Okay, good. Okay. Now, this is Fe2+ is being oxidized. Okay. And I told you these two are very good oxidizing agent. So let's say I use one of these, which is, let's say, for example, I use MnO4. Okay, I don't use the K. Yeah, K is a spectator ion, MnO4. Okay, MnO4 minus. Okay, and this is a oxidant or oxidizing agent that causes Fe2+ to change into Fe3+. Now, if MnO4 is an oxidizing agent. They will oxidize others, but they themselves will get reduced. So MnO4 will be reduced to become what? This is very important. It will become Mn2 plus. Memorize this. Okay? Always, yeah? What will happen to the O? We are going to do now. Always MnO4 minus, it will change into Mn2 plus. Remember this until you go to university. Okay? MnO4 minus will change into Mn2 plus. Now, this one, let's look at the observation. Now, these two are oxidizing agents that we can see something. There is a color change that will happen. Okay? The color change is going to be purple, and this is going to be colorless. Okay? The observation, purple will become decolorized. Okay? If let's say you manage to oxidize others. Yeah? Now, our work now is we have completed the half equation here, but this half equation is not completed. We need to complete the half equation and get the general equation. How do we complete this half equation? It is going to be similar with the way that we completed for OH minus just now. Now, for the OH minus, you have O changing into O2, okay, and hydrogen changing into water. Now, you have Mn changing into Mn2 plus, and Ishana was asking what happens to the O. Can you tell me, will it be O2 or something else? You guys are not paying attention. I repeat again like a grandma. There are very few reactions in chemistry, okay, that gives you oxygen. The special reaction that can happen in the lab, hydrogen peroxide, okay, when we use the catalyst MnO2, it will give you water and oxygen. That is very, very useful for us to test for oxygen gas. We call it a special reaction. There are certain reactions that you need to do additional work, which is the electrolysis. That gives you the oxygen like what I showed you just now. And some other reactions are photosynthesis. This is also a common chemical that I said that you can find in the lab, right? Did I say that this one can give you oxygen? No. So, forget about this. It will never happen. Okay? If you cannot give you oxygen, what are the other alternatives that you can give so that you can get oxygen? Good observation. Good observation. There is no H plus. Yeah, there is no H. Good. You notice that. Because that is what I'm going to come over here now. There is no hydrogen here. You have to put a hydrogen here. Can you put hydrogen in form of gas? No need. You put in form of H plus. That is the reason why we say acidified potassium manganate, acidified potassium dichromate. Without acid, it doesn't work. That's the reason. Okay, but not completed yet, yeah? Okay, not completed yet. Let's balance it. You see, oxygen is 4. You put 4. How many hydrogen? 8. You put 8. Is it done? Electron. So it means you look at the charge. This is 2 plus. This is 0. Overall charge on the right is plus 2. Let's look at the charge over here. This is plus 8. This is negative 1. Minus 8. Good. Who's your maths teacher? I'll tell. Mr. Chandi, I won't see Mr. Chandi for some time. You just need to rearrange, 8 minus 1. I think she was thinking that I'm praising her, yeah? So, okay, 8 minus 1 is going to be plus 7. Now, this is plus 7 on your left, okay, and this is going to be plus 2, okay, on your right. And what you need to do is to make the charges the same, okay? So you can bring in electron. You put the electron, it's going to make the number smaller. You put the electron over here, you make it smaller to become 2. How many electron do you add? No lah. This entire thing, the charge is negative 1. Just now I told you, right? So the entire is going to be negative. Yeah? It's always written like that. Maybe if I write like this, is it okay? K plus MnO4 minus. Overall negative 1, overall is positive 1. Then only they can come together. Okay? KOCl. Sometimes no need to separate them completely because you have K plus OCl can be, this entire thing is negative. So it's like that, certain cases, yeah. So here, this is plus 7. You want to make it plus 2, you add 5 electron, so it's minus 5. So you get plus 2 left and right. Now, once you get that, okay, we just need to combine them by trying to eliminate the electrons. How do we eliminate the electron? 1 electron, 5 electron times 5. Add left and right, the 5 electrons will cancel. So you will have MnO4 minus plus 5 Fe2 plus 8H plus 5 Fe3 plus Mn2 plus 4H2O. It's just longer stuff, but again, okay, it's completed. Okay. Now your work, I have shown you for this. Our time is done, right? Okay. I've shown you for manganate ion. What this is manganate ion, potassium manganate. This is going to be K2Cr2O7. Okay. They will change into Cr2O7 2 minus. Okay, when you separate. Okay, Ashana, listen. This is K2. Okay, this is K2. It means now this one must be 2 minus. Okay, K2, this one 2 minus. Now, they are going to change into Cr3 plus. Memorize, yeah? Just now, Mn2 plus. This one, they will change into Cr3 plus. And the observation, just now, purple to become colorless. This one is going to become orange to become green. How do I remember this? I remember like green is a very good color. I don't know, yeah? Or I do not know how you want to remember, yeah? So I remember orange to become green. And that is how the color will change. What I want you to do is, you go and write the equation. Maybe you use, this is the oxidizing agent. You can use Fe2 plus to become Fe3 plus. You try to write the overall reaction like this for this. It means Fe2 plus to become Fe3 plus. This is your work. I will go through this tomorrow. Okay? Done.